Good morning to all. I hope I discussed about how it will happen for the next 2 weeks in VLSI lab. So this is a short video. I'm preparing it for you to give instructions on how to use a Vivado tool when you are simulating the hardware. But before that, let me make the documents ready. 1 minute. 1 minute. Okay. Okay. So the first step when you are doing the simulation in your project, what you are supposed to do is that you have to go and select the Vivado tool in your desktop. So once you open the tool, this is the screen. You will be able to visualize it. And here you have to create a a new project, or here also you can create a create project. So I have clicked on create new project. Click next. The name of the project, what I am going to do is that I am going to implement a logic gates in this project. So I am giving my project name as project logic, and then click next. I am going to do an RTL based project. RTL stands for register transfer logic. And here, if you have already created a program in notepad file or a Verilog file, something you have created, you can add that files here and you can work on it. But now we are not going to do that. We are going to create the file. So I will just proceed with these things, and I will show how can I create the file on our own. That I will discuss it next few minutes. So now you just click next. Here also click next, and then you proceed. And here you have to select the targeted board. For which board you are going to select, what is the type of FPGA you are going to select. So here parts and boards are available. I hope you are able to see my pointer over there. So click here boards. Here you have to select the Z board and click next. Okay, so here boards, and then select the Z board what we are having in our lab, and then click next. So this is a summary of your project. I'm going to design an RTL based project. So no source file are included so far. And the Z board is what the targeted board, and the part number of the ICs, everything are included over here. So I'll just create by clicking the finish button in our project. So we have to wait until the updating is happening, till the creation of project is done. So now in the top right corner, you are able to see a ready button. Ready is available here. So now the project is created. It is our job to create a design file and to simulate all these things we have to create over there. And here I will just go and create in the top left corner below the project manager. I have add a source file. I hope you are able to see my pointer over there. Click here add a source, and there are options here. Either you have to add or create I want to create your design. So add or create a design source. It is not a constraint or simulation source. I am going to create the design source now. I am clicking on the design file, and here you create file. I am going to select the language to be VHDL. The name of the file, let me select it as a and underscore. Let me give something mar. That is the name of the indicate what I am going to create. The name of my indicate what I am going to create is and underscore mar. Okay, I will click OK. So this is the name of the VHDL file, and it has included the by default the Xilinx library file has been included. Now click here finish, and this is for entity. Previous name what you have given is for entity. I am now going to define the architecture name. I am going to define data flow, or I will just write a DF. Again I said the name of the entity is underscore Maran. The architecture name can be anything. Now I am just giving the architecture name as data flow. Some DF short form I wrote it as DF, or you can write your data flow underscore, and also I can write, that is not at all a problem. So I will just write data flow for indicate. I will write like this. Okay, anything is fine. It has not been created, or you want to share module definition is not changed. Are you sure you want to use this value? Yes. Again it will show here updating. So you can check here and under the design sources, there is one source file is being created. I hope here alone you have to be In the project summary, where the project is created, what is the targeted board, what is the module name, what is the targeted language. Here I have to select here VHDL. Here I have to select here VHDL, apply changes. Okay. And let the simulator language be mixed. And we have not yet started. So far synthesis has not yet started. These are the details of the board which from the Z-board website. All these things are there. And the next tab, it is given in the VHDL and underscore mar is MAR is the name of the file, what is where we are going to write our VHDL program. .vhd stands for VHDL. And as I said, VHDL program has three main component. Library definition file. Whether I don't know whether it is clear or not, how to show that. How can I use a magnifier? Okay. I hope here you are now able to see library IEEE colon use IEEE dot standard underscore logic underscore 1164 dot. All these things are by default created when you are creating a project, and there are some comment sections are there, and here the entity portion is there, where entity name of the entity is and underscore marn is, and here you have to define what are the portrait definitions, whatever you want to write on, and underscore marn. The architecture data flow underscore, and this is the name of the architecture what I am going to define for this particular entity. So architecture of of the data flow of and gate of and underscore mar. So this is the name of the entity is. Here I have to write my program, but here I will just write the port definitions. Okay, I will just erase this portion. I will write here 1 minute. PORT port. I will write A in standard logic in 1 minute. I will just open the document. I don't want to make any mistakes. I will just close the magnifier. Okay, and in space standard underscore logic. Okay, I will just copy this portion, copied, and I am writing it over here, followed by in the architecture portion I will write y is equivalent to a and b. So I have copied the program and placed it in the architecture portion. So this is the complete program what we are going to discuss. Okay, so here the entity I have defined the portrait definitions. A and B are in standard logic, Y is out standard logic, and the architecture named and underscore mar. And the architecture definition I am defining A equivalent to Y is equivalent to A and B. Okay, so this is the entire program what I want to work on. Now once the program is written, you can save this file, and here in the flow navigator, first I have created the source file. Now let us first convert this into an hardware. RTL means registered transfer analysis, whether the given program is able to be converted into hardware. I will analyze this one. I will click on open elaborated design. I will click here OK. It will run for a few seconds. We have to wait and just check whether our program has been converted to equivalent hardware or not. Yes. So now let us check what has been done. Yeah, the program whatever I write for a VHDL for AND-gate in VHDL language is converted into an equivalent hardware with a AND-gate. The name of the AND-gate is and underscore mar. Inputs are A and B and the output is Y. Fine. Now the hardware has been created. Now let us do the simulation part. Run simulation, go over the simulation, check whether the functionality is working correct or not. Okay, and I will I'm clicking on the run simulation. So this is a tab what you are able to see now. We'll just increase the zoom motion. You see here the A, B and Y. A and B are the inputs, Y is the output. In order to verify the simulation, just select over the variable whatever you want to give it as input, right click over there, give force constant. Okay, in the force constant, A is of binary data type, so here I am selecting the binary as a data type. I am giving the value of 1 and OK. Similarly, I have to do for Y, right click, force constant, it is of binary data type, binary type of input. I'm giving here 1, so I'm giving A and B both are 1 1 as inputs to my A and B inputs. To run the simulation for one instant of time, I will check what are the inputs I have given. Now you can see here the inputs are A is equivalent to 1, B is equivalent to 1, Y is also 1. Y is output of my. I am giving the inputs to my circuit of AND gate by providing A1, B1 and Y is equivalent to 1, and the outputs are also 1. Now sir, 1 okay, what about other inputs? Now you can go over here. I will select over there, right click, force constant. Now you give the value to be 0 here and check whether I'm making one of the inputs to be 0 now. Okay, A equivalent to 1, B is equivalent to 0. Now you again run the simulation, check whether it is working correct or not. You check here, when A equivalent to 1, B equivalent to 0, I was able to get the output is equivalent to 0. So let us check how does this works. You see now for first few seconds I'm giving 1 input, output is equivalent to 1. Second input I'm giving 1 0, the output is equivalent to 1. Now you can check the other input is also to be force constant with a value of binary with a value of 1. Just click over there and I will select here, run on the simulation. Where is it? Whether it is accepted or not. Giving force constant binary with a value of 0, click OK and run the simulation. Yeah, now the inputs are 0 0, output is equivalent to 1. So like that you can verify for each and every combination of inputs, you can run the simulation. Okay, now let us assume that I have what should I say, for each and every input I have to provide force constant like that I have to give. What is the other way I can give now? For example, let's assume that I have 4 input circuit something. For example, I am going to design a 4-bit triple carry adder now. A, B, C, D will be there. Then how many number of times you will have to run the input test vector now? A, B, C, D. Yeah, okay, or else A, okay, I will just take 1 minute. I'll just take a blank page. So let's assume that I have A0, A, B1, okay, fine, A2, A3, again here B0, B1, B2 and B3. So I am designing a 4-bit triple carry adder. Now I should have first full adder. Each full adder will have, first full adder will have A0, B0, second full adder have A1, B1, third full adder will have inputs of A2, B2, third last full adder will have A3, B3. So how many combinations of inputs you will provide now? For here 16 combinations are there, here 16 combinations are there, 16 into 16 totally 256. How many combinations? 16 cross 16, 256 combinations you have to test for simple 4-bit triple carry. How many times you will give force clock, so that is not a right way to do that. Okay, so what is the other way na? I can give the input such a way that it will work continuously. At the same time, I have to make sure that all the combinations are coming over there. So you see here, I am initializing the simulation tool here. I will just magnify. Okay, now you see here, I will go to the variable, right click. First time I gave force clock. Now if you want to give multiple inputs means then you can go for force clock. It is of binary data type, leading edge of 1, trailing edge of 0 to be 100, or I will give it to be 200 nanoseconds for A. For B, again I will do the same procedure. Binary, the leading edge of 1, trailing edge of 0. Here I will keep that B with a clock period of 100 nanoseconds. So now I will run the simulation. Okay, I have given the inputs. A is a clock cycle, B is also a clock cycle. I will check whether I have given it as B as a clock cycle or not. Yes, B is a clock cycle, leading edge 1, trailing edge 0, and with 15 nanoseconds. Yeah, fine. I have given A and B, both are clock cycles. Now let us run the simulation here. You see how does it works. You see how many inputs I have been created now. Okay, so previously when I click that simulation button, only one input is being accepted over there, but now it is a continuous clock cycles are being created for both A and B, and for the corresponding continuous simultaneous inputs of A and B, it has generated the output also. Let us check whether it is working correctly as an indicator or not. Let us move the marker here at some position. For 1 input, output is equivalent to 1. For 1 0 combination, output is equivalent to 0. 0 1 combination, output is 0. 0 0 combination, output is 0. So in this duration itself, I was able to get all the 4 combinations. Again, I will run the same thing: 1 1 1 0 0 1 or 0 0. All the 4 combinations are obtained. So this is how I was able to check by planning the time period of A and B clock cycles. I was able to verify all the functionalities in just one clock cycle. This will be very beneficial when you go for multiple input circuits. The force clock should be very useful for you. But what is the thing is that you have to plan accordingly. What is the period of your A, what is the period of B, such that you will get all the combinations that you have to plan and act accordingly. So this is how you can verify. You can write a program for your design in VHDL. You can design the check the RTL portion of it, and you can verify the simulation portion of it. Now after doing all these things, you have to implement it. Okay, now in this video let us stop over here. How to simulate till this portion, you be comfortable, then the next procedure we will continue on the next upcoming classes. Fine, thank you.